and CD here is equal to A minus B. So the area of the rectangle ABCD therefore would be equal to A squared minus B squared. Well, A squared minus B squared would be equal to what? To C squared. A, B, C, D, therefore, is equal to C squared. But C squared is nothing other than the area of the square. So we are done with this part. We just showed that any given rectangle is actually quadruple, meaning you can create or construct another square with the same area as that of your arbitrary rectangle. Okay, so we're still on the part one. Now we'll talk about the quadrature of the triangle. So let me just mark the borders here so you can see where I'm writing and I don't miss my mark. Okay. So this would be page 2, still part 1. So now we are going to demonstrate, or I'm going to demonstrate the quadrature of the triangle. Quadrature of the triangle. So we are going to start with some arbitrary triangle ABCD. So start with an arbitrary triangle ABC. So let me just draw the triangle here. Okay. Let me make it a little longer. So the triangle doesn't have to be special in any way, not right, nothing special about the triangle, some triangle. Okay, so this is triangle A, B, C. Alright, the next step I will be dropping from B the altitude of the triangle. Okay, so next, drop the altitude BD. So here's the altitude, and I'm calling this point D. And I'm going to bisect the line BD at some point. Let me call it point E. How do you bisect a segment? Just like I told you from the first slide, using the compass, it is possible to bisect the segment BD. So let's say this is the middle, and I will mark that by E, and bisect BD at at point E. So that's the middle point. Next, we are going to construct another rectangle. I'm going to call that rectangle GHJK. And let me construct a triangle. I'm not a triangle, but rectangle. And what would be special about this rectangle is that the height of the rectangle, or the smaller side, would be exactly the same length as half of BD, meaning either ED or BE. Okay, so this is rectangle GHJK. So construct, next, construct. I'm writing what I just did. Construct a rectangle GHJK such that GH and KJ are the same length as the base of our triangle. So same as the base AC, such that GH, it is equal to KJ, is equal to AC. And I said this length and this length are the same as this length. And JH is equal to KG is equal to ED is equal to BE. Okay. We want to show that the triangle is quadruple. In the first page, we just proved that given any rectangle, it can be squared, meaning any rectangle is quadruple. So here's a rectangle. Since I know from the previous page that it is possible to square this one, meaning this one is quadruple, then it'll suffice to show that the area of my triangle is the same as the area of this rectangle. And since this rectangle is quadruple, therefore this triangle will be quadruple. So that is the plan. So let me just mark with red exactly what we want to be of the same area. So we want to show that area of this rectangle is equal to the area of our triangle. Okay, that's the plan. Now, area of triangle ABC is equal to half the base times the height. So it is half the line AC, or its length or its magnitude, times the length BD. Okay. And also area of the rectangle GHJK, we know that to be base times height, or length times width. So it is the same as GH, length of GH times the length of JH. GH times JH. Okay, well, I know that GH is equal to AC from here. So area of the rectangle GHJK, instead of GH, I will write AC, because GH is equal to AC. So it is the same as AC. And JH, I know, is the same as ED. I made sure that they were of the same length. So instead of JH, I'm going to write ED. Okay. Well, ED is half BD. So area GHJK, I'm going to leave the AC alone, but AD is half of BD. So area GHJK, if you bring the half in front, is equal to half times the length of AC times the length of BD, but this is the same as the area of our triangle, and then we are done. Since the rectangle is quadruple and area of this rectangle is equal to area of this arbitrary triangle, then the triangle is also quadruple. Since rectangle GHJK is quadruple, then so is triangle ABC. And since triangle ABC was arbitrary, this argument works for absolutely any triangle. Okay, so that is the end of part 1. I'll move on to part 2.